To correctly wire a 480/240 delta 12 lead motor, it's crucial to understand the lead designations and connection schemes for both high voltage, which is 480 volts delta, and low voltage, which is 240 volts delta configurations. Let's begin with the high voltage 480 volts delta lead hookup. You will have three sets of leads designated as turn T2 and T3. Turn connects to one phase of your 480 volts power source. The typical lead color for turn is either black or red. T2 connects to the second phase of your 480 volts power source, typically with blue or yellow lead colors. Finally, T3 connects to the third phase of your 480 volts power source. The usual lead color for T3 is orange or green. Now let's discuss the low voltage 240 volts delta lead hookup. In this configuration, you will be connecting certain leads together to achieve the 240 volts delta configuration. T5, with typical lead colors of black or red, is connected to tone. 6, which is typically blue or yellow, is connected to T2. 7, often orange or green, is connected to T3. Essentially, you are pairing up these leads. You'll also have some additional leads that need to be considered. T8 is usually designated as neutral. T9 is for ground and should be connected to the motor frame to ensure proper grounding. Leads T10 through T12 are typically not used in either the 480 volts delta or 240 volts delta configurations. Please note that the lead colors may vary depending on the motor manufacturer. Therefore, it is imperative to verify the lead connections carefully before powering the motor. Incorrect wiring can cause damage to the motor and create a safety hazard. Always double-check your connections against the motor's wiring diagram. Ensuring the motor is properly grounded is also critical for safety. A proper ground connection provides a path for fault current in case of an insulation failure, which helps prevent electrical shock hazards. It's also very important to refer to the motor manufacturer's instructions for specific connection requirements. Motor manufacturers often provide detailed wiring diagrams and instructions that are specific to their particular motor models. These instructions will provide the most accurate and up-to-date information for your motor. In summary, when wiring a 480/240 delta 12 lead motor, firstly, identify the voltage configuration you need, either 480 volts delta or 240 volts delta. Secondly, correctly connect the tone, T2 and T3 leads for the 480 volts delta configuration, or connect T5 to tone, 6 to T2, and 7 to T3 for the 240 volts delta configuration. Thirdly, ensure that T9 is connected to the motor frame for proper grounding. Finally, always verify your connections and consult the motor manufacturer's instructions before powering the motor. Remember that safety is paramount when working with electrical equipment. If you are not comfortable working with electricity, it is best to consult a qualified electrician. It is good practice to use a multimeter to verify the voltage at the motor leads before connecting the motor. This will help to ensure that you are connecting the motor to the correct voltage source. If the voltage is incorrect, do not connect the motor and investigate the cause of the incorrect voltage. Also, be sure to properly torque the motor lead connections. Loose connections can cause overheating and potentially lead to a fire. Refer to the motor manufacturer's instructions for the proper torque specifications. After connecting the motor, it is a good idea to check the motor's rotation. If the motor is rotating in the wrong direction, you can swap any two of the three-phase leads to reverse the rotation. It's also important to protect the motor from overloads and short circuits. Use properly sized fuses or circuit breakers to protect the motor. The size of the fuses or circuit breakers should be based on the motor's nameplate current rating. Furthermore, use properly sized conductors. The conductor size should be based on the motor's full load current and the applicable electrical codes. Remember that motor starting current can be several times higher than the full load current, so be sure to account for this when selecting the conductor size and overcurrent protection. It's a good idea to use a motor starter with overload protection to protect the motor from overloads. Motor starters are designed to handle the high inrush current of motors and provide overload protection that is specifically designed for motors. When installing the motor, be sure to provide adequate ventilation to prevent the motor from overheating. Motors generate heat, and if the heat is not dissipated properly, the motor can overheat and fail. Follow the motor manufacturer's recommendations for ventilation. Regularly inspect the motor for signs of wear and tear, such as damaged insulation, loose connections, or excessive vibration. If you find any problems, have the motor repaired by a qualified technician. A well-maintained motor will last longer and operate more efficiently. Selecting the correct motor for the application is critical. Consider the load requirements, speed requirements, and environmental conditions when selecting a motor. Using the wrong motor for the application can lead to premature failure. Always consult with a qualified engineer to determine the best motor for your application. When replacing a motor, be sure to use a motor with the same horsepower, speed, voltage, and frame size as the original motor. Using a motor with different specifications can cause problems. Also, consider using an energy-efficient motor. Energy-efficient motors can save you money on your electricity bill and reduce your carbon footprint. Be sure to properly dispose of the old motor. Many motor components can be recycled. Contact your local recycling center for information on how to recycle your old motor. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment such as safety glasses and gloves. Always to energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized before you begin work. Never work on live electrical circuits. If you are not comfortable working with electricity, consult a qualified electrician. Remember, working with electricity can be dangerous, so always take precautions to protect yourself. In addition to the above, let us review some more nuanced aspects of three-phase motor connections. Understanding the implications of delta connections is key. In a delta connection, the three windings are connected in a closed loop forming a triangle, which gives rise to the term delta. The voltage across each winding is equal to the line-to-line voltage of the supply. This is the primary advantage of the delta configuration, as it allows the motor to operate at the full line voltage. However, the current in each winding is not equal to the line current. The line current is equal to the square root of 3 times the winding current. This means that the windings must be sized to handle the higher winding current. Now about the 12 leads specifically. The 12 leads allow for different voltage connections and configurations. By connecting the leads in different ways, the motor can be operated at different voltages. This is useful in applications where the supply voltage may vary. For instance, the motor is designed to run on both 480 volts and 240 volts. By connecting the leads in the high voltage configuration, the motor can be operated on 480 volts. By connecting the leads in a low voltage configuration, the motor can be operated on 240 volts. The 12 leads also allow for reversing the motor's direction of rotation. By swapping any two of the three-phase leads, the motor's direction of rotation can be reversed. This is useful in applications where the motor needs to be able to rotate in both directions. Another thing is motor protection. Proper motor protection is essential to prevent motor damage. Motors can be damaged by overloads, short circuits, undervoltage, and overvoltage. Overload protection protects the motor from excessive current draw due to mechanical overload. Short circuit protection protects the motor from high currents caused by short circuits. Undervoltage protection protects the motor from damage caused by low voltage. Overvoltage protection protects the motor from damage caused by high voltage. Motor protection devices typically include fuses, circuit breakers, and overload relays. Fuses and circuit breakers provide short circuit protection. Overload relays provide overload protection. Some motor starters also include undervoltage and overvoltage protection. Selecting the correct motor protection devices is critical to ensure proper motor protection. The size of the fuses or circuit breakers should be based on the motor's full load current and the applicable electrical codes. The overload relay should be sized to protect the motor from overloads without nuisance tripping. And there's also motor efficiency. Motor efficiency is the ratio of the mechanical power output to the electrical power input. Motors are not 100% efficient, and some of the electrical power is lost as heat. Higher efficiency motors convert more of the electrical power into mechanical power and generate less heat. Energy efficient motors can save you money on your electricity bill and reduce your carbon footprint. Motors are available in a variety of efficiency ratings. The efficiency rating is typically indicated on the motor's nameplate. When selecting a motor, consider the motor's efficiency rating. For applications where the motor will be running for long periods of time, an energy-efficient motor can be a good investment. And a final important point to consider is the motor's operating environment. The motor's operating environment can have a significant impact on the motor's performance and lifespan. Factors such as temperature, humidity, and altitude can affect the motor's operation. High temperatures can cause the motor to overheat and fail. High humidity can cause corrosion and insulation breakdown. High altitude can reduce the motor's cooling capacity. When selecting a motor, consider the motor's operating environment. Motors are available in a variety of enclosures that are designed to protect the motor from the environment. Open drip-proof enclosures are suitable for clean, dry environments. Totally enclosed vent-cooled enclosures are suitable for dirty, dusty environment. Explosion-proof enclosures are required for hazardous environments where flammable materials are present. Remember that electrical safety is paramount. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. Always de-energize the circuit before working on it, and use a voltage tester to verify that the circuit is de-energized before you begin work. Never work on live electrical circuits. If you are not comfortable working with electricity, consult a qualified electrician. It is always best to err on the side of caution when working with electricity. Regular motor maintenance is also important to extend the life of the motor. The most basic maintenance task is to keep the motor clean. Dust and dirt can accumulate on the motor and prevent it from cooling properly. Use a brush or vacuum cleaner to remove dust and dirt from the motor. Also, lubricate the motor bearings regularly. The frequency of lubrication will depend on the type of bearings and the motor's operating conditions. Refer to the motor manufacturer's instructions for lubrication recommendations. Inspect the motor for signs of wear and tear, such as damaged insulation, loose connections, or excessive vibration. If you find any problems, have the motor repaired by a qualified technician. Vibration can be a sign of imbalance or bearing problems. Ignoring vibration can lead to further damage. Another factor is the ambient temperature. Motors have a maximum ambient temperature rating. Exceeding this rating can lead to overheating and premature failure. Consider the ambient temperature when selecting a motor. If the motor will be operating in a high temperature environment, select a motor with a high temperature rating. It's also worth considering the motor's duty cycle. The duty cycle is the percentage of time that the motor is running. Motors are designed for different duty cycles. Continuous duty motors are designed to run continuously. Intermittent duty motors are designed to run for short periods of time followed by a period of rest. Selecting the correct duty cycle is important to prevent motor overheating. Using a motor with an incorrect duty cycle can lead to premature failure. Let's talk about harmonic distortion as well. Harmonic distortion is the presence of harmonic frequencies in the power supply. Harmonic distortion can cause motors to overheat and fail. If you suspect that your power supply has harmonic distortion, consider using a harmonic filter. Harmonic filters can reduce the amount of harmonic distortion in the power supply. Another important aspect is grounding. Proper grounding is essential for electrical safety. Grounding provides a path for fault current in case of an insulation failure. This helps prevent electrical shock hazards. The motor should be grounded to a common grounding point. The grounding conductor should be sized according to the electrical codes. Be sure to check the condition of the grounding conductor regularly. A corroded or damaged grounding conductor can compromise electrical safety. And finally, let's discuss surge protection. Power surges can damage motors. Surge protection devices can protect motors from damage caused by power surges. Surge protection devices should be installed at the service entrance and at the motor. Selecting the correct surge protection devices is important to ensure proper protection. Remember that following these guidelines will help you properly connect and maintain your 480/240 Delta 12 lead motor, ensuring its safe and efficient operation for years to come.